This tutorial video is designed to help you remember some of the different ways that we can factor polynomials. And we're going to solve these quadratic functions by factoring, which means we're going to look for x in each case, or down here we actually have a j. We are going to solve for those letters by factoring and then setting the factors equal to 0. So let's start with the first one, which is probably the easiest one. We are first going to notice that there is an a value attached to that x squared. So I'm going to attempt to factor it out of all three terms, which I can because all three terms are divisible by 2. So I'm going to take a 2 out, and that leaves me with x squared plus 6x plus 9, and that's all equal to 0. Now, you can think about it this way. If we were to divide both sides by 2, then the 2 would just disappear because 2 divided by this 2 here would cancel those terms out, and then 0 divided by 2 is still 0. So I can actually set x squared plus 6x plus 9 equal to 0 as well. But I'm going to leave it here because I don't really need to get rid of it right now. Now that I have this polynomial in the middle here, I am going to try and factor that. So my 2 is hanging out front unless I divide it off, which I'm choosing not to. And I'm looking for two numbers that add to my b value and multiply to c. So I'm going to write that off to the side here. Add to b, multiply to c. And those numbers are going to be 3 and 3, because 3 plus 3 is 6, and 3 times 3 is 9. So I've got x plus 3, x plus 3. And I can even go so far as to group these two together since they are the same and write 2x plus 3 squared equals 0. Now, what I want to do is set this x plus 3 equal to 0. And that means that my x value has to be -3, because -3 plus 3 is 0, or I could get x by itself. I could isolate it by subtracting 3 from both sides. So that is my solution to this equation. Since there is only one solution here, I know that this parabola opens upwards because it has a positive a value, and it rests on the x-axis at the point x equals -3, and there are no other roots to this quadratic. Let's look at the next one. Now, we want to factor out this 3, but unfortunately we can't do that because 4 and 7 are not divisible by 3, so it's going to make it a little bit messy. So I'm going to try a different strategy here. I'm going to find two numbers that add to my b value, which is +4, but this time I'm looking for numbers that multiply to a multiplied by c. So that's going to end up being 3 times -7, which is -21. The two numbers that add to +4 and multiply to -21 is going to be +7, -3. And I'm going to split this x term into 7x minus 3x, because 7x minus 3x is still 4x, so I'm not changing the equation at all. And I'm going to split that so that I can group the first two terms together and the second two terms together, and then I can factor out a common coefficient. So I'm going to have 3x squared over here, and I'm actually going to put the -3x on the left because then I notice that both of these terms are divisible by 3. And I'm going to put that +7x on the right because, again, I know that I can factor a 7 out of both of these terms. So I'm actually going to group them together so that I can factor out the common factors there. So I'm going to take a 3x out of this one because both of them have a 3, but both of them also have an x. So 3x I'm taking out, and I'm left with x minus 1. And I'm adding the 7 I'm going to pull out and x minus 1. Now, notice how I've got x minus 1 in both cases, which is really good. That's what I want, because now I can factor out the x minus 1, and I'm left with 3x plus 7. And now I can set both of these equal to 0, and I can solve for x. So I've got x minus 1 is equal to 0, which means x is +1. And I also have 3x plus 7 is equal to 0, so that means I'm going to have x is equal to negative 7 over 3, because I'm going to subtract 7 from both sides, and then I'm going to divide both sides by 3, and I end up with negative 7 over 3 for that one. So I have two roots in this solution, which means the parabola is crossing the x-axis twice, and again, it's a parabola that opens upwards because I have a positive a value. Let's take a look at this last example here. Now this is a little bit tricky because you got to put two ideas together. So the first idea is that I'm noticing that this is a difference of squares. I'm going to make a note of that. Difference of squares. So difference means that I'm subtracting, and squares means that I have two squared terms. Now, you could think of it this way. It's kind of like having x squared subtract y squared. So this is my x term and this is my y term. It's a difference of squares. And a difference of squares tells us that my solution is going to end up being x plus y, x minus y. So I'm just going to put the example over here, my difference of squares, and my solution is x plus y, x minus y. So I'm going to pretend that this is an x term and this is a y term, and I'm going to organize it like this. So I'm going to take my x term, and I'm going to write big brackets like this so that I don't get confused, because I got to keep all this stuff inside. So I'm going to take my x term, which is 4j minus 2, so that's my x, and I'm going to add my y term, which is over here. So plus 2 plus 4j. And I am multiplying that by x minus y. So I'm going to take my x term again, which is 4j minus 2, and I'm going to subtract my y term, which is 2 plus 4j. And now I'm going to simplify this because it's a little bit of a mess right now. So I'm noticing here that I've got a negative 2 and a positive 2. So I'm going to cancel those two terms out. And then I end up putting the two 4j's together because I have 4j plus another 4j. That's going to give me 8j. Okay, and then I'm going to do a similar thing over here. Now I have negative 2 minus 2, which is going to give me a negative 4. But then I'm going to have 4j subtract 4j over here. So those cancel out, and I'm left with negative 4. And now I can set my equation equal to 0. And the only way that this is going to work out to be 0 is if j is equal to 0. So that would be where the parabola would sit on my graph, is at x equals 0, or in this case we have j is equal to 0. So I hope that little refresher reminded you of some of the strategies that we use to factor polynomials. And again, this is stuff that you've learned from previous years, so hopefully it's in your toolbox. This is just a little reminder of some of the things that you're expected to remember when you're looking at these types of problems.